Good morning to one and all present here. So today's topic for discussion is timer, which is going to work in mode 1 of 8051. So we have two timers in 8051, timer 0 and timer 1. So I am going to brief you all today about timer, which is going to work in mode 1. So it's a 16-bit timer. And we have TL0, TH0, which is going to store the 16 bits of the timer. So the overall function of the timer is that it will start counting from the values what you have loaded in TL0, TH0. And once you start with the timer, it is going to roll back to 0, and that is the time when your TF flag is going to be raised. The user has to keep monitoring the TF flag so that it understands that much amount of delay has been created. So over here we have, when the timer reaches its maximum of FFFF, it rolls over to 0000 and the TF flag is raised. This is the time when the user understands that the particular delay has been executed. These are the various steps of programming a timer in mode 1. So first you configure your TMOD register. Your TMOD register is nothing but a 8-bit register which has 8 values starting from value that is I0 to I7, and the first 4 bits that is starting from your LSB is for timer 0, and the next 4 bits are allocated for timer 1. We have the first 2 bits as M0, M1, which is going to select the mode of the timer. Since we have already in mode 1, which is 16-bit timer, the values will be going in M0, M1. Then we have C/T bar, which is going to tell us whether a timer is selected or a counter. And finally, we have the gate bit. So the gate bit is going to tell us whether the control is software controlled or it is a hardware controlled timer. So the value which goes in TMOD register is 0, 1. So now 0, 1 indicates that this value is going to be 0, 0, 0, 0, and this is 0, 0, 0, 1. So since it is 0, 1, the M0 bit is 1, M1 bit is 0, it tells that timer 0 is going to operate in mode 1, which is a 16-bit timer. After we select the mode of the timer, we set the values in TH0, TL0 registers. So the value which is going in is FFFCH. After this, the timer will be started, and once the timer starts, it is going to start ticking. That means this value will keep on incrementing. It will reach the last value, which is FFFF, and finally the rollover will happen to 0000. At that particular point, my TF flag is going to be raised. Once the TF is raised, it indicates that particular delay is completed and it is the time to clear the timer flag. And once that is done, we have the delay created. So this is a pictorial representation of the timer. So the FFFC, which goes in TL0, TH0, we have started the timer. It will keep on incrementing, and once the rollover happens from FFFF to 0000, at that time the timer should be stopped and the TF flag is raised to 1. This is the time when the user tells the user that your delay is completed. So this is the program for that. It has the TF is raised to 1. We are waiting for the TF flag to become 1. Once it is 1, we are stopping the timer and we are clearing the flag. So this is the entire process of timer 1, timer working in mode 1. This is how my delay is calculated. So here the value which you put in the TL, TH registers is inserted in this formula. So FFFF minus, in our example what we just saw, it was FFFC plus 1 into 1.085 microseconds. This 1.085 microseconds is coming from this crystal frequency which we are using for the crystal oscillator. So this frequency you divide by 12 and then you take the inverse of it is this delay, which is 1.085 microseconds. Similarly, you will be calculating this in decimal. So this FFFF is converted as 65535. This Y by XX is converted into decimal as NNNNN. 1 is as it is, 1.085 microseconds remain as it is. So this is how the delay is calculated. So you have a short program over here which is actually generating a square wave, which the application of which is blinking of LED. So here it is going to generate a square wave on port 1.5 and we have to use a crystal oscillator of 11.0592 megahertz. So we have first configured the T-mod register. Now since you see that this 1 is nothing but 0001, it is telling us that timer 1 is used, which is in mode 1, which is 16-bit timer. Since we are talking of 16-bit, we have loaded TL1, TH1 with some value. We have started the timer. Now we are waiting for the flag to be raised. The moment the flag is raised, it will come out of this loop. It will clear the flag. It will complement whatever is there on port 1.5 and it will clear the flag and then it will say SJump again. So suppose for example initially port 1.5 had 0. It will start your timer, it will wait for that flag to be raised. The moment that much amount of delay has been finished, it will come out of this loop and it will say clear the timer. That means it will stop your timer. It will complement whatever is there. So initially it was 0, it will complement that. So this is the amount of delay which is generated by this value over here. You clear your flag and then the cycle continues. So that is how you generate a square wave on port 1.5, which is going to help you blink the LED. Concept of timer working in mode 1 is clear. Thank you.